Okay, so now we're continuing on page 1. We're going to do the square root method, completing the square in the quadratic formula. So I don't have a lot of room to write, so I'm going to have a piece of paper I'm going to try and do the work on. So let's see here. We have to use the square root method for this. So this is the only time that you're going to use square root is when you just have n squared on there, okay, and constant values, and that's it. So don't try to use square root when you're trying to factor or anything like that. Nothing silly. That's an indicator that we know that you don't know what the heck you're doing. So just make sure that you don't incorporate square roots, anything in the factoring part of it. Square root method is just used for the square roots. You'll only see square roots when you're trying to solve something like, with completing the square or maybe quadratic formula aside from that. So don't get too antsy with the square roots because you won't need them other than this. Anyways, so for number 9, we start off with the expression 8n squared plus 10 is equal to 210. And then we use the square root method to solve. So I'm going to show my work over here. So first what I want to do is get the n squared all by itself. That's my ultimate goal, so then I can take the square root. So I use order of operations to solve this out. So I want to get rid of any addition, subtraction first. So I have to get rid of that plus 10. So I subtract 10 from both sides. So I get 8n squared is equal to 200. Next, before I get rid of that exponent, I want to get rid of any multiplication or division. Since I'm multiplying by 8, I want to get rid of that multiply by 8, so I divide both sides by 8. So I get n squared is equal to 200 over 8, which is 25. Next, I take the square root of both sides. So square root this side, square root this side. Now when I take the square root of a square, they cancel each other out. So I just have n by itself. And then the square root of 25 is 5. Now, here's one thing that you have to remember for these problems, because they can be really easy, but there's one little thing at the end that you have to remember. When you take the square root of a squared variable, you have to put a plus or minus in front at the very end. So just make sure to put a plus or minus there, because it accounts for the 2 solutions that you get for your n. So just make sure that you do that. Number 10, so we've got 4n squared minus 9 is equal to negative 18. So let's get the n squared by itself again. So we add 9 to both sides. So plus 9, plus 9. That eliminates the negative 9, and we have 4n squared is equal to negative 18 plus 9 is going to be a negative 9. Now, to get the n squared by itself, we divide both sides by 4. And we get n squared is equal to negative 9 over 4. Then we take the square root of both sides, so we get n is equal to plus or minus the square root of negative 9 over 4. Now, as soon as you see that negative under the square root, you need to remember that we can't have negatives in our final answer, so we're going to move the negative out into the front. And this makes this an imaginary number, so with the negative moved out front, it turns into an I. So that means that we have plus or minus I times the square root of 9 over 4. And then you can simplify it a little bit further. So when you take the square root of a fraction, take the square root of the top part and the square root of the bottom part. So the square root of 9 is 3, so we get plus or minus 3. And then square root of 4 is 2, so over 2 in the bottom. And then our I value after that. So this is our final answer for n. One of the answers is positive 3 over 2i, and one of the answers is negative 3 over 2i. I'm sure that if you reduced it all the way to here, you'd probably have the majority of your points. This is just kind of icing on the cake for that part. Okay, so that's numbers 9 and 10. Now we're going to do number 11. So we're going to complete the square. So I'm going to do this 2 different ways. One way is just by the methods that we go on in our notes, and then another way just using a formula that automatically completes the square for you every single time. All right. So these are the steps that we go through to solve using completing the square. First, we add 31 to both sides. So that gives us v squared plus 6v equals, and then 31 minus 5 is 26. Now we need to turn this into a perfect square. So what we do is we take the number that's the b value in our standard form, in other words, the number that's multiplying on the variable that's by itself, not the square variable, but just like the variable to the first power. So in this case, it's a 6. And we divide that number by 2. So 6 divided by 2 gives us 3. So let's keep that in mind. So 3 is the number that I get ultimately when I divide this by 2. So I get v plus 3. That's going to be my perfect square on the left-hand side. And on the right-hand side, I get 26 plus 3 squared. All right. So we're really close to solving. V plus 3 squared stays the same on that side. Let's go ahead and add this stuff up. So 26 plus 3 squared is 9. 26 plus 9 gives me 35. So next what I'm going to do is take the square root of both sides. So square root here, and I get v plus 3 is equal to the square root of 35. And remember, if we take the square root of a squared variable, we have to put a plus or a minus in front. Now to get the v by itself, we just simply subtract 3 from both sides. V is equal to negative 3 plus or minus the square root of 35. Since you can't reduce this radical any further, you can just stop right there, and those are your two answers for v. All right, so the other way that you can do this, instead of learning this process of just the same steps over and over again, there's a formula that you can use to just complete the square right away. Here's how the formula looks. So you first have to get 0 on one side, so 0 is equal to, and then it'll be a times parentheses your variable, let's call it x, so x, and then plus, and then a parentheses, and it's going to be the b value over 2 times the a value. And then outside the parentheses, we're going to square it. And then it's plus your c value, just like the c that you get in the quadratic formula. And then minus the b value over 2 squared. Yeah, that's about it. So let's go ahead and work through this problem and complete the square and solve. Okay, so using the same exact equation that we have, v squared plus 6v minus 31 equals negative 5. I add 5 over to both sides first, and I get v squared plus 6v, and then minus 26 is equal to 0. So we've got it in the form that we want, where it equals 0. Now we label our a, b, and c values just like in quadratic formula. So a is equal to 1, b is equal to 6, c is equal to negative 26. And then we plug it into the formula. So we get 0 is equal to our a value is 1, so 1 times parentheses, our variable v, plus, and then parentheses, our b value, which is 6, over 2 times a, so 2 times 1, and then squared, plus c, so c is negative 26, and then minus our b value squared, so our b values, which is 6 over 2 squared. Okay, so continuing on with this, we get v plus, and then 6 over 2 is 3, so plus 3 squared, and then we've got minus 26, and then we've got this negative, and then 6 over 2 is 3, and 3 squared is 9, so minus 9. All right, so negative 26 and a negative 9 makes a negative 35. And then the whole thing equals 0. So I'm almost actually to this point right here. All I need to do is just add the 35 to both sides. So I get v plus 3 squared is equal to, I'm going to move the 35 over there, so 35. And then we just kind of follow the same steps that we did over here. We take the square root of both sides, so that'll be v plus 3 is equal to the square root of 35. And then don't forget the plus or minus that goes out front there. And then the last step is just to get the v by itself. So subtract 3 from both sides, and you get v is equal to negative 3 plus or minus the square root of 35. Should sound familiar because it's the same answer that we got previously. 2 different ways to do the completing the square. You can just memorize this formula, or you can just memorize the method to get to that point. All right, so that's number 11. Now we're just going to do 2 real quick ones, number 12 and number 13, and that's where we have to use the quadratic formula. So the quadratic formula looks like this. If you're looking for solutions x to a quadratic, you write it out in standard form, and then you use the formula. It's negative b, so the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2a. Okay, so for number 12, we have 5n squared plus 11n plus 11 equals 0. So we label our a, b, and c values because it's in standard form. We have the square and then the regular variable and then the constant equals 0. That's standard form. So a is equal to 5, b is equal to 11, c is equal to 11. So we plug it into the formula. So negative of b, 11, plus or minus the square root of b, which is 11, squared, minus 4 times a, which is 5, times c, which is also 11. That's all over 2 times a, and a in this case is 5. All right, so I can do some of the multiplication, just because I see it and it's recognizable. Like the negative of 11 is negative 11. That's pretty easy. And then 11 squared, you may or may not know, but that's 121. 4 times 5 is 20, so minus 20 times 11. And then all that over 2 times 5, so that's 10. Now, you could try to multiply this out in your head and subtract values. I'm just going to use my calculator to finish this off. So 121 minus 20 times 11, and I get negative 99. So negative 99 is my answer for underneath the square root, so negative 11 plus or minus the square root of negative 99 over 10. I'm going to show you that you could have gotten negative 99 just by plugging in all the stuff under the square root, as long as you're careful and put your parentheses around those numbers. Okay, so I'm going to get negative 99 just by plugging this stuff in too. So parentheses 11 parentheses squared minus 4 times parentheses 5 times parentheses 11. And see, I get negative 99 still. So even if you just wanted to plug it in up here, you'd still get the same answer. Anyways, so continuing with this, the negative again needs to become an I, an imaginary number, so we put that out front. So we get negative 11 plus or minus I times the square root of 99 over 10. And I'm pretty sure that your teachers would probably accept this as an answer if you wanted to go a step further and reduce the radical. 99 is the same thing as saying 9 times 11. And you can take the square root of 9. The square root of 9 is 3, so this becomes 3 radical 11. So if you wanted to get some extra points, just put that 3 square root of 11 instead of the square root of 99. So you end up with negative 11 plus or minus 3 times I on the outside of the square root, and then the square root of 11 over 10. So that would be if you reduced your radicals and all that stuff. Okay, the last problem on this page is number 13. So for number 13, we've got 7x squared plus 8x minus 21 is equal to 0. It's in standard form, so we label a, b, and c. A equals 7, b equals 8, c equals negative 21, and then plug it into the formula. So we've got the negative of b, which is 8, plus or minus the square root of 8 squared minus 4 times a times c, all over 2 times a. All right, so that's the same as saying negative 8 plus or minus the square root of, and let's just go ahead and do all that in our calculator right now. So parentheses 8 squared minus 4 times parentheses 7 times parentheses negative 21. Make sure to press the negative button and not the minus button, because otherwise you might get an error message on your calculator. Hit enter, and we get 652. And that's all over 2 times 7, which is 14. Well, I don't know about 652. Let's take the square root of it to see if it's an even square root. It is not, so I'm just going to leave it as it is. And maybe I could reduce it a little bit further, but for the purposes of this test, we don't really test on that stuff, so this would be a correct answer for it. All right, so that's the end of the first page. Now we'll start up on the second page.